March 19th, 1943. Somewhere in North Africa, approximately 8 miles south of El Guettar, Tunisia, Lieutenant Colonel Wilhelm Schmalz, commanding officer of the German 135th Panzergrenadier Regiment, pressed field glasses to his eyes and watched American artillery positions through the heat shimmer of the Tunisian desert. He had spent the previous 18 months fighting across Russia, where German artillery had proven technically superior to anything the Soviets could field. He had witnessed the destruction of entire Soviet divisions under precisely coordinated German fire. Now, watching the American guns deploy across the valley, he prepared his post-action report in his mind. The assessment would be clinical, professional, dismissive. American artillery doctrine appeared primitive. Their fire discipline was adequate at best. The crews moved with the mechanical efficiency of factory workers rather than the precision of trained artillerymen. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Within 6 hours, every assumption Colonel Schmalz held about artillery warfare would be shattered by a volume of fire he had never imagined possible. The mathematics of American victory were being written not in tactical doctrine or superior technology, but in production statistics that would prove more devastating than any weapon design. The transformation had begun 3 years earlier, on a telephone call that lasted 7 minutes. June 7th, 1940, Rock Island Arsenal, Illinois. Colonel Charles Harris, commanding officer of the United States Army's primary artillery manufacturing facility, reviewed production reports that revealed a crisis approaching. The arsenal employed 800 skilled craftsmen who had spent decades mastering the art of precision machining. These men could produce artillery pieces that met exacting specifications, guns that would last for decades of service. They could also produce exactly 3 complete 105mm howitzers per month. At that rate, equipping a single infantry division with the required 36 howitzers would take 12 months. The United States Army had 67 infantry divisions scheduled for activation by 1942. Traditional manufacturing approaches would require 67 years to equip them adequately. Colonel Harris understood artillery production through a lens shaped by 40 years of military tradition. Artillery pieces were precision instruments requiring skilled craftsmen to hand-fit components, adjust tolerances, and ensure perfect mechanical operation. Each gun was essentially unique, built by specialists who had served apprenticeships lasting years. The idea that artillery could be manufactured any other way seemed incomprehensible. 300 miles to the northeast, a different perspective was emerging. Executives at industrial corporations across the American Northeast and Midwest were receiving telephone calls from Washington. William Knudsen, former president of General Motors and newly appointed director of industrial production, was asking questions that seemed absurd on their face. Can your automobile factories build artillery pieces? Can heavy equipment manufacturers produce gun carriages? Can machine tool companies create the specialized equipment needed for mass production? The responses varied, but a pattern emerged. Industrial engineers who had never built weapons examined the specifications and recognized something military arsenals had missed. A 105mm howitzer was not fundamentally different from any other precision mechanical assembly. It consisted of approximately 2,000 individual components that needed to be manufactured to specific tolerances and assembled in a particular sequence. The fact that it fired explosive projectiles rather than assembling automobiles did not change the underlying manufacturing challenge. The German High Command observed American mobilization efforts with amusement bordering on contempt. German artillery had been refined through centuries of military tradition. The Wehrmacht employed the finest artillery pieces in the world, manufactured by Krupp and Rheinmetall, companies that had been building guns since the 1800s. German gunners trained for years before achieving master status. The idea that American civilians could challenge this expertise seemed laughable. In confidential assessments circulated among Wehrmacht artillery commanders in late 1940, the consensus was clear. American artillery production might increase numerically, but quality would inevitably decline. Mass-produced guns would lack the precision of hand-fitted German artillery. American gunners, hastily trained, would never achieve the fire discipline of Wehrmacht artillery battalions, and most importantly, American industry would never produce ammunition at rates sufficient to support sustained operations. These assumptions would prove catastrophically wrong, but in mid-1940 they represented conventional military wisdom shared by every professional army in the world. Artillery was a specialized craft requiring specialized facilities, specialized workers, and years of experience. The scale of production could be increased somewhat, but only within the constraints of traditional manufacturing approaches. The first challenge to this wisdom came from an unexpected source. The Rock Island Arsenal, facing impossible production demands, made a decision that horrified traditional artillery manufacturers. They would release complete engineering specifications to civilian contractors and allow private companies to bid on artillery component production. This had never been done before. Military arsenals guarded specifications zealously. The precision required for artillery components was assumed to exceed civilian manufacturing capabilities. In September 1940, the first contract awards went to companies that had never built weapons. A gear manufacturer in Pennsylvania received contracts for breech mechanisms. A hydraulic equipment manufacturer in Ohio would produce recoil systems. A steel foundry in Michigan would cast gun barrels. A machine shop in Wisconsin would produce firing mechanisms. Each contractor received specifications, technical assistance from Rock Island Arsenal engineers, and a delivery schedule that seemed impossible by traditional standards. The first shipments arrived at Rock Island Arsenal in January 1941. Master gunsmiths who had spent their careers hand-fitting artillery components examined the civilian manufactured parts with deep skepticism. They expected crude approximations requiring extensive rework. What they discovered instead was precision that matched or exceeded Arsenal standards. The Pennsylvania gear manufacturer had used automotive-grade machine tools that held tolerances within thousandths of an inch. The Ohio Hydraulics Company had adapted aircraft manufacturing techniques. The Michigan foundry had developed specialized casting methods that produced barrels requiring minimal machining. Most significantly, the civilian manufacturers produced components that were completely interchangeable. In traditional arsenal production, each gun required individual fitting. Barrels were matched to receivers. Recoil systems were adjusted for specific guns. Sighting mechanisms required calibration for each weapon. This hand-fitting process was what made artillery production so labor-intensive and time-consuming. The civilian manufactured components eliminated this requirement entirely. A barrel manufactured in Michigan fit any receiver manufactured in Pennsylvania. A recoil system from Ohio installed in any carriage without adjustment. This interchangeability represented a fundamental transformation in artillery manufacturing philosophy. It meant that final assembly could become a mechanical process rather than a skilled craft. By March 1941, Rock Island Arsenal had assembled 12 complete 105mm M2A1 howitzers using civilian manufactured components. This equaled 4 months of traditional production, but more significantly, the civilian contractors were just beginning to ramp up their production capacity. The arsenal had traditionally thought about artillery production in terms of individual guns built sequentially by skilled craftsmen. The civilian contractors thought about production in terms of manufacturing systems that could scale indefinitely. Their factories could add shifts, hire workers, install additional machine tools, and increase output in ways that were impossible under traditional arsenal approaches. The implications were staggering. If artillery could be manufactured using industrial production methods, then the constraints that had limited military production for centuries no longer applied. Production was no longer limited by the number of skilled craftsmen available. It was limited only by the availability of raw materials, machine tools, and factory capacity. In May 1941, representatives from Detroit automotive companies visited Rock Island Arsenal to examine artillery production. They brought a perspective shaped by decades of mass production experience. Henry Ford had demonstrated that complex mechanical assemblies could be built on moving assembly lines by workers with minimal training. General Motors had proven that standardized components manufactured to precise tolerances could be assembled at unprecedented speeds. Chrysler had shown that specialized manufacturing equipment could dramatically reduce production time. The automotive engineers studied the M2A1 Howitzer and saw not a weapon but an assembly problem. The gun consisted of approximately 2,000 components. Many of these components were similar to automotive parts. The recoil system used hydraulic principles identical to automotive shock absorbers. The carriage used wheel bearings, axles, and suspension systems similar to heavy trucks. The breech mechanism operated like an oversized automotive transmission. The sighting system used optical principles similar to automotive headlights. They proposed something that seemed impossible to military engineers. Build howitzers on assembly lines using automotive production methods. Manufacture components in specialized facilities using high-speed machine tools. Deliver components to final assembly plants using just-in-time logistics. Assemble complete guns on moving lines with workers performing specialized repetitive tasks. Quality control through statistical sampling rather than individual inspection of every component. Rock Island Arsenal engineers objected strenuously. Artillery required precision that exceeded automotive standards. The stresses involved in firing high-explosive shells far exceeded anything encountered in automobile operation. The reliability requirements for combat weapons demanded individual attention to every component. Mass production might work for automobiles, but artillery was different. The automotive engineers had one irrefutable argument. The United States needed to produce thousands of artillery pieces per month. Traditional methods could never achieve this volume. Either mass production approaches would work, or American ground forces would go into combat without adequate artillery support. There was no third option. In June 1941, a pilot program began at a converted automotive parts plant in Pennsylvania. The facility had previously manufactured truck transmissions. Now it would attempt to manufacture artillery components using automotive production equipment and methods. The first attempts were disasters. High-speed machine tools designed for softer automotive metals shattered when used on the hardened steel required for gun barrels. Welding techniques that worked perfectly for automotive body panels created weak points in artillery carriages. Assembly line workers, accustomed to light automotive components, struggled with the weight and size of artillery parts. The Pennsylvania plant's first month of operation produced exactly 0 completed components and dozens of expensive failures. Traditional arsenal engineers considered this proof that their skepticism had been justified. Artillery manufacturing required specialized knowledge that could not be replicated in civilian factories. The experiment had failed, and production should return to proven arsenal methods. But the automotive engineers saw something different. They saw a learning curve. Every manufacturing process encounters problems during initial implementation. The question was not whether problems existed, but whether those problems could be solved through systematic engineering. They attacked each problem individually. Machine tools were modified with specialized cutting heads designed for hardened steel. Welding procedures were developed specifically for artillery applications. Handling equipment was designed to move heavy components safely and efficiently. Training programs were created to teach workers the specific skills needed for artillery component manufacture. By August 1941, the Pennsylvania plant was producing 50 sets of artillery components per month. By October, 150 sets per month. By December, 300 sets monthly. The production increase was not linear, it was exponential. As workers gained experience, they moved faster and made fewer mistakes. As engineers identified bottlenecks, they redesigned processes to eliminate constraints. As management refined logistics, component flow improved dramatically. This was the power of systematic industrial production applied to weapons manufacturing. Traditional arsenal production improved incrementally over decades through accumulated craftsman experience. Industrial production improved geometrically over months, through systematic problem-solving. December 7, 1941, changed everything. The Japanese attack on Pearl Harbor transformed the cautious industrial mobilization into desperate urgency. The United States was at war, and American ground forces would need artillery immediately. The War Department issued production orders that seemed impossible. The Army needed 1,105 mm howitzers per month. This represented more than 300 times Rock Island Arsenal's traditional production capacity. Meeting this requirement would require complete transformation of artillery manufacturing. The decision was made in late December 1941. Artillery production would shift entirely to mass production methods. Rock Island Arsenal would focus on design, testing, and quality control oversight. Actual manufacturing would occur at civilian facilities using industrial production equipment and methods. Dozens of factories across the United States received contracts to manufacture artillery components. Each facility specialized in specific components based on their existing equipment and expertise. A plant in Chicago manufactured gun barrels using specialized boring equipment developed for railroad cylinder boring. A facility in Detroit produced recoil systems using hydraulic equipment originally designed for aircraft landing gear. A factory in Milwaukee manufactured carriages using heavy steel fabrication equipment built for agricultural machinery. A plant in Buffalo produced breech mechanisms using precision machine tools designed for marine engine manufacture. Each facility operated independently, shipping components to final assembly plants. The final assembly plants were newly constructed facilities designed specifically for artillery production. They followed automotive assembly line principles with modifications for the size and weight of artillery components. The largest assembly plant was built in Pennsylvania, constructed in 90 days during winter 1941 and 1942. The facility measured 800,000 square feet under one roof. 3 parallel assembly lines ran the length of the building. Each line could accommodate 30 guns simultaneously at various stages of assembly. Overhead cranes moved major components from storage areas to assembly positions. Specialized carts carried smaller parts to workers at each station. The entire facility was designed around the principle of continuous flow. Components entered at one end, and completed howitzers emerged at the other end. No gun ever sat stationary waiting for parts or workers. Everything moved constantly forward through the assembly sequence. The first guns rolled off the Pennsylvania assembly line in March 1942. Production that month was 87 complete howitzers. This exceeded Rock Island Arsenal's entire annual production using traditional methods, but it was nowhere near the War Department's requirement of 1,000 guns per month. The challenge was not technical. The assembly line could physically produce guns far faster than current rates. The constraint was workforce training and supplier synchronization. Assembly line work requires workers to perform specific tasks repeatedly with mechanical precision. This specialization allows rapid training. A worker does not need to understand how an entire howitzer functions. They only need to master the specific operation they perform dozens of times per day. Traditional arsenal craftsmen had trained for years to gain comprehensive knowledge. Assembly line workers trained for 2 weeks to gain specialized knowledge. By May 1942, the Pennsylvania plant employed 3,000 workers operating in 3 shifts, covering 24 hours. Daily production reached 18 howitzers. Monthly production approached 550 guns. The plant was approaching its design capacity. To meet the 1,000 guns per month requirement, additional assembly plants would be needed. Construction began on a second assembly facility in Illinois. A third plant was planned for Ohio. Simultaneously, component suppliers were expanding their production. The initial suppliers had been selected based on existing capacity. Now they were building additional capacity, specifically for artillery production. The Chicago barrel plant doubled in size. The Detroit recoil facility added a second production line. The Milwaukee carriage plant installed additional fabrication equipment. Each supplier's expansion was coordinated with assembly plant requirements to ensure synchronization. By September 1942, the system was achieving the impossible. The Pennsylvania plant was producing 580 howitzers per month. The newly completed Illinois plant added 320 per month. Combined production exceeded 900 guns monthly. With the Ohio plant scheduled to open in November, the 1,000 guns per month target would be met. But the War Department had already increased requirements. The army was expanding faster than originally planned. Infantry divisions needed 36 howitzers each. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Armoured divisions needed 54. Separate artillery battalions needed 12. Total requirements now exceeded 1,500 howitzers per month. The response was not to build more assembly plants, it was to make existing plants more efficient. Industrial engineers studied every aspect of the assembly process, identifying opportunities for improvement. The time required to move a gun carriage from one station to the next was reduced from 12 minutes to 8 minutes through improved crane scheduling. The time workers spent walking to parts storage was eliminated by positioning parts at each workstation. The time lost during shift changes was minimized by staggered breaks. These small improvements accumulated into dramatic production increases. The Pennsylvania plant that had produced 580 howitzers in September produced 680 in October, 750 in November, 830 in December. Each month's improvement came from systematic optimization of every step in the assembly process. By January 1943, combined production across all three assembly plants exceeded 1,600 howitzers per month. This was not the most remarkable aspect of the transformation. The most remarkable aspect was what happened to production costs and quality. Traditional Rock Island arsenal production had cost approximately $25,000 per howitzer in 1939. This reflected the skilled labor required for hand-fitting and the small-scale manufacturing of components. Mass production reduced costs to $18,000 per howitzer by late 1942. The cost reduction came from multiple sources. Automated machine tools produced components faster than hand machining. Specialized assembly line workers cost less than master craftsmen. High-volume purchasing of raw materials negotiated better prices. Standardized designs eliminated custom engineering for each gun. Perhaps most significantly, the learning curve effect meant that each successive gun cost less to produce than the previous one. Quality actually improved under mass production. Traditional arsenal production had relied on master craftsmen to ensure quality through individual attention to each gun. But craftsmen were human. They had good days and bad days. They made mistakes. Quality varied depending on which craftsman built which gun. Mass production replaced craftsman judgment with statistical quality control. Every component was manufactured to precise specifications that were verified through measurement. Any component outside specifications was rejected before assembly. Assembly line workers followed detailed procedures that eliminated variation. Completed guns were tested using standardized vibrators, procedures that identified any problems before delivery. The result was consistent quality that actually exceeded the average quality of hand-built arsenal guns. German artillery officers receiving intelligence reports about American production could not believe the numbers. 1,600 howitzers per month seemed impossible. German artillery production in early 1943 was approximately 400 guns per month across all calibers and types. The idea that the Americans were producing 4 times as many guns of a single type seemed like propaganda or miscalculation. But the numbers were accurate. By March 1943, American artillery production exceeded German and Italian production combined. The guns themselves were unremarkable by German standards. The M2A1 was a conventional design using technology developed in the 1920s. Its maximum range of 12,000 yards was adequate but not exceptional. Its rate of fire was standard. Its reliability was good but not superior to German guns. In technical specifications, the M2A1 was an average artillery piece. What made it devastating was not its technical characteristics, but its availability in overwhelming numbers. Each American infantry division deployed with 36 M2A1 howitzers. Each division also had 12 155mm howitzers for longer-range fire. Additionally, separate artillery battalions could be attached to divisions as needed. A typical American division offensive in 1943 might involve 96 artillery pieces supporting the attack. German divisions typically deployed with 36 guns total. The ammunition situation was even more asymmetric. American artillery production included massive ammunition manufacturing capacity. By mid-1943, American factories were producing more than 10 million artillery shells per month. This equaled the entire German artillery ammunition production for 6 months. American gunners could fire ammunition at rates that would have been considered wasteful extravagance by German standards. Colonel Schmalz would learn this lesson at Guettar. On March 19, 1943, his regiment advanced toward American positions expecting conventional artillery support. German doctrine called for careful ammunition conservation, guns fired deliberately, each shell carefully aimed to maximize effect and preserve limited ammunition stocks. The American response was unlike anything he had experienced. The first American artillery barrage opened at 09:30 hours. 12 batteries, 72 guns total, fired simultaneously on the German advance. The volume of fire was staggering. In the first 10 minutes, approximately 2,000 shells landed on a front less than 1 mile wide. This equaled the ammunition a German artillery battalion might fire in an entire day of heavy combat. The barrage continued for 40 minutes without pause. German troops who survived described it as experiencing an earthquake combined with a thunderstorm. The second lesson came during the German counterattack. Wehrmacht doctrine emphasized concentrated firepower at the point of attack. German artillery would mass fire on the breakthrough point, suppressing American defenders while Panzergrenadiers advanced. But American artillery responded differently. Within minutes of the German attack beginning, American counter-battery fire began falling on German gun positions. Not sporadic harassing fire, but sustained, overwhelming bombardment that silenced German guns almost immediately. The speed and intensity of the American response reflected systematic advantages that went beyond gun numbers. American artillery battalions deployed with advanced fire direction centers that could coordinate fire from dozens of batteries simultaneously. Forward observers with reliable radio communications could call for fire that arrived within minutes. Ammunition supply chains ensured that guns never ran short of shells. The entire system was designed for sustained, overwhelming firepower. Colonel Schmalz withdrew his regiment that evening, having lost more than 40% of his combat strength. His post-action report, recovered from German archives after the war, reveals the psychological impact of the American artillery system. He wrote that American gunners showed little tactical skill or fire discipline. They wasted ammunition extravagantly. But the sheer volume of fire made tactical skill irrelevant. No amount of training or experience could prepare troops for the intensity of American artillery bombardment. Similar reports began flowing into Wehrmacht headquarters from North Africa, Italy, and eventually France. German commanders consistently noted that American artillery showed poor fire discipline and wasted ammunition. What they failed to understand was that this waste was deliberate strategy. American doctrine recognized that overwhelming firepower achieved objectives faster and with fewer casualties than carefully rationed fire. The ability to fire ammunition liberally was not wasteful extravagance, but systematic advantage. The production statistics that supported this doctrine were staggering. By mid-1943, American factories were producing 2,000 howitzers per month. Total production for 1943 would exceed 21,000 artillery pieces of all types. German production for the same year was approximately 6,000 guns. Soviet production was higher than American in raw numbers, but lower in technical sophistication. British production was substantial but still less than half American output. What made these numbers possible was the complete transformation of manufacturing philosophy that had begun with those telephone calls in June 1940. Traditional military arsenals had viewed artillery as specialized equipment requiring specialized production. American industry had recognized artillery as mechanical assemblies requiring systematic manufacturing. This perspective shift enabled production at scales that traditional approaches could never achieve. The system extended far beyond howitzer production. The same principles were applied to every category of military equipment. Tanks that had required 9 months to build in government arsenals were rolling off Chrysler assembly lines every hour by late 1942. Aircraft that had been hand-built by skilled craftsmen were emerging from Ford's Willow Run plant at rates exceeding 1 per hour. Ships that had required years to build were being launched in days from Kaiser's yards. In each case, the transformation followed the same pattern. Traditional craft production was replaced by industrial mass production. Specialized skills were replaced by systematic procedures. Small-scale manufacture was replaced by high-volume production. The constraints that had limited military production for centuries were systematically eliminated through industrial engineering. The result was productive capacity that exceeded the combined output of all other major powers. The human cost of this transformation deserves recognition. The workers who built these weapons were not military personnel. They were civilians who answered their country's call by taking factory jobs. Many were women entering industrial work for the first time. Many were older workers who had retired but returned to contribute. Many were young people who learned trades in weeks that traditionally required years to master. They worked conditions that would seem intolerable by modern standards. The Pennsylvania Artillery Assembly Plant operated 24 hours daily, 7 days weekly, with no holidays. Summer heat inside the unair-conditioned facility often exceeded 100 degrees. Winter cold penetrated the massive building despite heating systems. The work was physically demanding, mentally exhausting, and offered little recognition or glory. Yet they persisted. Production records show minimal absenteeism despite difficult conditions. Workers frequently volunteered for overtime when production goals were not met. Many assembly plants reported instances of workers staying late without pay to complete production runs or fix problems that threatened delivery schedules. This dedication was driven partly by patriotism, partly by economic necessity during wartime, but also by something deeper. The workers understood that the guns they built would be used by American soldiers in combat. Every howitzer that left the assembly line might mean the difference between victory and defeat for some infantry unit thousands of miles away. This direct connection between factory work and battlefield success created powerful motivation. Workers were not building products for customers. They were building weapons for their brothers, sons, and neighbors who were fighting overseas. The transformation also affected communities far beyond the factory floors. The Pennsylvania Artillery Assembly Plant employed 3,000 workers at its peak. Most had relocated to the area specifically for these jobs. Housing, schools, transportation, and services all expanded rapidly to accommodate the influx. Small towns near major war production facilities grew into substantial communities almost overnight. This demographic shift created social tensions, infrastructure challenges, and cultural changes that persisted long after the war ended. By late 1943, American artillery production had achieved something unprecedented in military history. The United States was producing more artillery pieces monthly than most nations produced annually. The guns themselves were not superior to German or British designs. They were simply available in quantities that made numerical superiority overwhelming. An average American infantry division in late 1943 could call on more artillery support than an entire German corps. The ammunition situation was even more dramatic. American factories in 1943 produced approximately 120 million artillery shells of all calibers. This equaled roughly half of total German ammunition production for the entire war. American gunners in Italy during 1944 averaged more than 60 shells per gun per day. German gunners in the same theatre averaged less than 10. This disparity reflected not better guns or better gunners, but better production systems. German military planners understood they were losing the production battle. Captured documents from 1944 show Wehrmacht assessments that acknowledged American numerical superiority. But these assessments continued to emphasize that German guns were technically superior, German gunners better trained, and German tactics more sophisticated. This was cold comfort to German infantry units enduring American artillery barrages that seemed to never end. The Eastern Front provided the clearest demonstration of artillery's decisive role. Soviet artillery production exceeded American output in raw numbers. Soviet multiple rocket launcher systems like the Katyusha created devastating area bombardments. But Soviet ammunition production could not sustain the intensity of fire that American logistics enabled. By 1944, American Lend-Lease was supplying significant quantities of explosives and propellants to Soviet factories, indirectly supporting Soviet artillery operations. The Western Front showed American artillery at its most effective. The Normandy invasion in June 1944 involved more than 5,000 artillery pieces supporting the landings. Naval guns supplemented ground artillery with bombardments that dwarfed anything previously attempted. The breakout from Normandy in late July 1944 featured artillery concentrations that fired more than 100,000 shells in single barrages. German defenders described these bombardments as apocalyptic experiences that destroyed morale as much as physical positions. By late 1944, German commanders were no longer laughing at American artillery. They feared it. Post-war interviews with German veterans consistently identified American artillery as the most effective Allied weapon. Not tanks, which were often inferior to German armor. Not aircraft, though Allied air superiority was significant. Artillery caused the most casualties, created the most psychological trauma, and most effectively suppressed German defensive fire. The production statistics that enabled this dominance continued to climb. Peak American artillery production occurred in early 1944, when monthly output exceeded 2,500 howitzers of all types. Total American artillery production for World War II exceeded 88,000 pieces. Germany produced approximately 70,000 guns during the entire war. The Soviet Union produced more than 90,000. Britain produced approximately 40,000. But American guns were backed by ammunition production that exceeded all other powers combined. The post-war assessments revealed something that German generals had failed to grasp during the fighting. Artillery effectiveness was not primarily determined by gun design or crew training. It was determined by industrial production capacity. A technically inferior gun available in large numbers with unlimited ammunition was more effective than a technically superior gun available in small numbers with limited ammunition. This lesson had been demonstrated definitively by American artillery performance. The M2A1 howitzer remained in service with the United States Army through the Korean War and Vietnam War. Many were supplied to Allied nations, where some remained in service into the 21st century. The last M2A1s in front line. American service were retired in 1989, 48 years after the first production guns were built. This longevity reflected solid engineering and robust construction, but the M2A1's real significance was not its technical specifications. Its significance was proving that artillery could be mass-produced using industrial methods without sacrificing reliability or effectiveness. This demonstration transformed military production permanently. After World War II, no major military power attempted to return to pre-war arsenal production methods. The industrial production approaches developed for the M2A1 became standard practice worldwide. Modern artillery production still follows principles established in those converted automotive plants during 1941 and 1942. The lesson extends beyond artillery to military production generally. The United States entered World War II with minimal military-industrial capacity. The Army in 1940 ranked behind Portugal in military power. But industrial production capacity, when properly mobilized and systematically organized, created military capability that exceeded centuries-old military powers within months. This transformation was possible because American industry recognized that weapons were mechanical assemblies amenable to mass production techniques. Traditional military establishments resisted this recognition. They viewed weapons as specialized equipment requiring specialized production. They believed that craftsman skills accumulated over years were essential for quality weapons manufacture. They assumed that production could only increase incrementally within constraints of traditional methods. American industry proved every one of these assumptions wrong. The howitzers that bombarded German positions at Guettar, Normandy, and throughout the European campaign were not superior weapons. They were adequate weapons, available in overwhelming numbers. The crews that served them were not better trained than German gunners. They were adequately trained soldiers backed by unlimited ammunition and sophisticated fire control systems. The tactics that employed them were not revolutionary. They were conventional tactics executed with overwhelming material superiority. Material superiority was the American way of war, and artillery production epitomized this approach. The German military tradition emphasized superior training, superior tactics, and superior technology to offset numerical disadvantages. The American approach accepted numerical superiority as the decisive advantage and mobilized industrial capacity to achieve it. Neither approach was inherently superior, but in World War II's circumstances, American industrial production proved more effective than German military tradition. The transformation of artillery production from craft to industry required less than 2 years. From the first telephone calls in June 1940 to 1,600 howitzers per month in January 1943 represented 20 months. Traditional military thinking would have considered such rapid transformation impossible, but industrial engineers approached the challenge without preconceptions about what was possible. They saw a mechanical assembly problem and applied systematic industrial solutions. Every obstacle encountered was treated as an engineering problem with engineering solutions. When machine tools failed, engineers developed new tools. When workers lacked skills, training programs taught required skills. When components did not fit together, tolerances were refined. When production rates were insufficient, processes were optimized. No problem was accepted as insurmountable. Every problem was solved through systematic analysis and methodical implementation. This problem-solving culture was fundamentally different from traditional military arsenals. Arsenals accepted certain constraints as inherent limitations. Industrial producers rejected inherent limitations and viewed all constraints as temporary obstacles. This philosophical difference explained why civilian factories outproduced government arsenals despite lacking specialized military experience. The willingness to question assumptions and engineer solutions proved more valuable than decades of specialized experience. By war's end in August 1945, American artillery production totaled more than 88,000 pieces. These guns had fired billions of shells across every theater of war. They had supported every major American offensive from North Africa through Germany and from Guadalcanal through Okinawa. They had provided the firepower foundation that enabled American ground forces to overcome opposition, despite often fighting with inferior numbers and equipment in other categories. German generals' dismissive laughter at American artillery in 1940 had transformed into grim respect by 1945. Post-war memoirs by German commanders consistently acknowledged that American artillery superiority was decisive, not because American guns were better, but because American production made them ubiquitous. Wherever American forces fought, artillery support was overwhelming. German forces might have local advantages in armor or infantry, but they never had artillery superiority after early 1943. The story of American artillery production is ultimately a story about industrial transformation. It demonstrates that manufacturing capacity, when properly organized and systematically applied, can overcome what appear to be insurmountable obstacles. The United States did not have better metallurgists than Germany or more skilled machinists than Britain. What it had was industrial production capacity that could be mobilized rapidly and scaled indefinitely. This capacity existed because American industry had spent decades perfecting mass production techniques for civilian goods. The automotive industry had developed systematic approaches to manufacturing complex mechanical assemblies. The machine tool industry had created equipment capable of precision work at high speeds. The steel industry had built capacity for producing vast quantities of specialized alloys. When war came, these civilian capabilities were redirected to military production with remarkable speed. The transformation was not smooth or easy. Thousands of problems were encountered and solved. Millions of workers had to be trained. Billions of dollars had to be invested in facilities and equipment. But the systematic approach that American industry brought to the challenge made success inevitable. It was not a matter of whether artillery could be mass-produced, but only how quickly production could be ramped up. German military planners failed to understand this reality. They continued to believe that quality would overcome quantity, that superior training and tactics would offset material disadvantages, and that American production numbers were exaggerated propaganda. By the time they recognized their error, the war was lost. American artillery had not won the war alone, but it had made German victory impossible by ensuring that every American offensive was supported by overwhelming firepower. The howitzers themselves were eventually scrapped or transferred to Allied nations. The factories that built them returned to civilian production or were demolished. The workers who assembled them returned to peacetime lives. But the lessons learned about industrial production and military mobilization shaped American defense policy for the next 7 decades. The recognition that industrial capacity was a strategic weapon informed Cold War planning and remains relevant today. 20 minutes of manufacturing time in a Detroit automotive plant converted to artillery production proved more decisive than centuries of German military tradition. This was the lesson of American artillery in World War II. Not that American guns were better, but that American production was overwhelming. Not that American gunners were superior, but that American industry could supply unlimited ammunition. Not that American tactics were revolutionary, but that American manufacturing made conventional tactics devastatingly effective through sheer material superiority. Colonel Schmalz learned this lesson at Guettar. Thousands of other German officers learned it across Italy, France, and Germany. The Wehrmacht entered the war believing that superior training and equipment would overcome numerical disadvantages. They ended the war understanding that industrial production capacity was the decisive factor in modern warfare. The guns that taught this lesson were unremarkable in design but revolutionary in their availability. The mathematics were brutal and simple. An American infantry division in 1944 could fire more artillery shells in 1 day than a German division could fire in 1 week. This ratio reflected not tactical doctrine or weapon superiority, but production capacity. American factories produced shells faster than German factories could replace casualties. American logistics delivered ammunition to the front faster than German supply systems could distribute their limited stocks. The breaking point came in different places at different times, but the pattern was consistent. German units fought skillfully with courage and determination until American artillery made their positions untenable. Then they withdrew, reformed, and fought again until the next artillery bombardment forced another withdrawal. This grinding attrition was not dramatic or heroic. It was systematic destruction through industrial superiority. The Battle of the Bulge in December 1944 provided the final demonstration. German forces launched their last major offensive in the West, achieving tactical surprise and initial success. For several days, German armor and infantry advanced through American lines, creating a dangerous bulge in Allied positions. But German artillery support was limited by ammunition shortages. Wehrmacht gunners fired carefully, conserving shells for critical targets. American artillery responded with characteristic excess. Once the initial shock wore off and reinforcements arrived, American guns began systematic bombardment of German positions. Artillery battalions fired continuously, day and night, without regard for ammunition conservation. Supply trucks delivered shells as fast as guns could fire them. Within days, German forward positions were being hit with thousands of shells daily. German artillery, limited to dozens of rounds per gun per day, could not respond effectively. General Patton's Third Army, redeploying from the south to hit the German flank, brought with it more than 400 artillery pieces. The bombardment that preceded the Third Army's attack fired more than 40,000 shells in less than an hour. German defenders, already weakened by days of continuous bombardment, could not withstand this concentration of fire. The bulge was eliminated not through tactical brilliance, but through overwhelming firepower that reflected overwhelming production capacity. Post-war analysis showed that American artillery caused approximately 70% of German casualties in the European theatre. This ratio was higher than in any previous war, and reflected both the effectiveness of American artillery systems and the intensity of American fire. German forces faced artillery bombardments of duration and intensity unprecedented in military history. No amount of tactical skill or defensive preparation could overcome this material disadvantage. The Pacific theater showed similar patterns with different circumstances. Japanese forces built elaborate defensive positions on islands across the Pacific. Their defensive doctrine emphasized concealment, camouflage, and interior positions, protected from naval bombardment. American forces responded with artillery concentrations that simply pulverized defended areas. On Iwo Jima, American artillery and naval guns fired more than 40,000 tons of shells onto an island measuring just 8 square miles. Every square yard of the island received multiple shell impacts. Japanese defenders survived these bombardments through deep tunnels and reinforced bunkers, but they emerged from shelters to face American infantry, supported by artillery that could be called instantly on any target. Japanese counterattacks were broken up by artillery fire before they could close with American positions. Japanese strongpoints were systematically destroyed by artillery forward observers who could call for fire that arrived within minutes. The result was grinding attrition that favored the side with unlimited ammunition and systematic firepower. The production system that made this possible continued to improve throughout the war. The Pennsylvania assembly plant that had produced 580 howitzers in September 1942 produced 940 in September 1944. This increase came not from facility expansion, but from continuous process improvement. Workers developed more efficient techniques. Suppliers delivered components with better synchronization. Management refined scheduling to minimize delays. Quality control became more sophisticated, reducing rejects and rework. These incremental improvements accumulated into dramatic production increases. The average time required to assemble one howitzer dropped from 18 hours in early 1942 to 11 hours by late 1944. This reduction came from thousands of small optimizations that individually seemed insignificant, but collectively transformed productivity. It represented the power of systematic industrial management applied to weapons production. The cost reductions were equally dramatic. The cost, $18,000 per howitzer cost, in late 1942 fell to $14,000 by mid-1944. This reduction occurred despite rising wages and material costs throughout the war. It reflected learning curve effects, improved efficiency, and better supplier negotiations. Mass production not only increased output but reduced unit costs, making weapons more affordable even as quantities increased. German artillery production showed the opposite trend. As Allied bombing damaged factories and raw material shortages intensified, German production costs increased while output declined. By 1944, German artillery factories were producing fewer guns at higher costs than in 1942. The industrial base was deteriorating under sustained bombing and resource constraints. Skilled workers were being drafted for military service, leaving factories undermanned. Allied air attacks disrupted supply chains, making it difficult to deliver components to assembly plants. The comparison was stark. American artillery production in 1944 was 3 times higher than in 1942, with lower unit costs and better quality. German production in 1944 was 60% of 1942 levels, with higher costs and declining quality. This divergence reflected not just Allied bombing, but fundamental differences in industrial organization and production philosophy. American industry had built flexible production systems that could absorb disruptions and maintain output. Multiple suppliers for each component meant that damage to one factory did not stop production. Standardized designs meant that alternative manufacturers could be brought online quickly. Systematic quality control meant that problems were identified and corrected before they affected large quantities. The entire system was engineered for resilience and scalability. German production relied on specialized manufacturers, producing custom components with limited interchangeability. Damage to a key factory could halt production for months until repairs were completed or alternative sources found. Design variations between manufacturers meant that components were not always interchangeable. Quality control was less systematic, relying more on craftsman skill than standardized procedures. The system was optimized for peacetime production, not wartime disruption. By early 1945, the production disparity had become overwhelming. American factories were producing more than 2,000 artillery pieces per month. German production had fallen below 200 per month. American ammunition production exceeded German production by more than 10 to 1. The material imbalance made German military resistance increasingly futile. Wehrmacht forces fought skillfully and courageously, but they could not overcome the firepower disadvantage. The final battles in Germany showed American artillery at its most devastating. Urban combat typically favored defenders, who could use buildings and rubble for cover and concealment. But American forces approached German cities with artillery bombardments that reduced defensive positions to rubble before infantry advanced. The assault on Cologne in March 1945 involved more than 300 artillery pieces firing into the city for 2 days before ground troops entered. Similar bombardments preceded assaults on Frankfurt, Nuremberg, and dozens of smaller cities. German military leaders recognized too late that they had fundamentally misunderstood modern warfare's requirements. They had prepared to fight a war decided by tactical skill and operational excellence. They found themselves fighting a war decided by industrial production capacity and logistical superiority. Their artillery was well designed and skillfully employed, but insufficient in quantity and inadequately supplied with ammunition. American artillery was adequately designed and conventionally employed, but overwhelming in quantity and backed by unlimited ammunition. The contrast appeared in the simplest operational details. A German artillery battery in 1945 might have 60 rounds per gun available for an entire day of combat. These shells would be fired carefully at high-priority targets identified by forward observers. An American battery on the same day might have 600 rounds per gun available, with additional ammunition on trucks nearby ready to resupply. American gunners could fire entire barrages on suspected enemy positions without confirmed targets, knowing that ammunition would be replenished. This profligacy horrified German officers accustomed to careful ammunition management. They viewed American fire as wasteful and undisciplined, but American doctrine recognized that suppressing enemy positions through overwhelming fire was more effective than precise fire on confirmed targets. The ability to fire ammunition generously was not waste but strategic advantage purchased through industrial production capacity. The human factor in this transformation deserves final recognition. The American artillery system involved hundreds of thousands of people performing specialized tasks: artillery crew members who loaded and fired guns, forward observers who directed fire, fire direction center personnel who calculated firing data, ammunition handlers who moved shells from storage to guns, truck drivers who delivered ammunition to forward positions, factory workers who manufactured guns and shells. All performed their tasks with competence and dedication that made the system function. These people were not superior humans with special abilities. They were ordinary Americans trained to perform specific tasks within a larger system. The system's effectiveness came not from individual excellence, but from systematic organization that allowed ordinary people to achieve extraordinary results. This was the fundamental insight that made American artillery dominance possible. Build systems that work consistently rather than relying on exceptional individuals to overcome systemic limitations. Traditional military organizations had emphasized developing exceptional soldiers through intensive training and experience. American industry emphasized developing effective systems through systematic design and continuous improvement. Both approaches had merit, but in World War II's circumstances, systematic approaches proved more effective than individual excellence. An adequate system staffed by trained personnel outperformed an improvised system staffed by experts. The M2A1 Howitzer itself embodied this philosophy. It was not an exceptional weapon. Its design was conventional, using proven technology rather than innovations. Its performance was adequate rather than superior. Its reliability was good but not remarkable. But it was manufactured in quantities that made it ubiquitous, and it was supported by ammunition production and logistics that made it effective. Adequacy, multiplied by abundance, defeated excellence constrained by scarcity. This lesson extended far beyond artillery. American military production during World War II proved that industrial capacity was a strategic weapon as important as any technology or tactics. The ability to produce weapons, ammunition, vehicles, and supplies in overwhelming quantities changed the fundamental nature of warfare. Victory went not to the side with better soldiers or better weapons, but to the side that could produce adequate weapons in unlimited quantities. The post-war world was shaped by this recognition. The United States maintained substantial industrial production capacity and developed the ability to rapidly expand that capacity during crises. NATO defense planning assumed that Western industrial capacity would offset Soviet numerical advantages in equipment and personnel. The Cold War became as much a competition in production capacity as in military capability. The recognition that wars were won in factories as much as on battlefields became fundamental to strategic planning. The story of American artillery production is ultimately a story about industrial transformation applied to military requirements. It shows that systematic approaches to manufacturing can overcome what appear to be insurmountable obstacles. It demonstrates that production capacity, when properly organized, can create military capability that exceeds centuries-old military traditions. And it proves that ordinary people working within well-designed systems can achieve results that experts working with inadequate systems cannot match. The workers who assembled howitzers in Pennsylvania factories never received medals or recognition comparable to combat soldiers. The engineers who designed production systems never achieved fame comparable to weapon designers. The managers who coordinated supplier networks never appeared in history books alongside generals, but their collective contribution to Allied victory was as important as any battlefield heroics. They built the material foundation that made victory possible. The guns they built fired their last shots in August 1945 when Japan surrendered. Many howitzers remained in service for decades afterward, testament to solid engineering and robust construction. But the M2A1's true legacy was not its service life, but its demonstration that weapons could be mass-produced without sacrificing effectiveness. This demonstration transformed military production permanently and shaped defense industrial policy for generations. German generals who laughed at American artillery in 1940 learned by 1945 that industrial production was more important than tactical excellence. The lesson cost Germany the war and changed military thinking worldwide. Modern militaries no longer dismiss industrial capacity as secondary to tactical skill. They recognize that production capacity is a form of combat power as important as training or technology. This recognition traces directly to American artillery production during World War II. The M2A1 howitzer, unremarkable in design and conventional in operation, proved revolutionary in its availability. 20,000 howitzers built in 3 years exceeded what traditional arsenals could produce in a century. This was possible because American industry recognized that artillery was a mechanical assembly amenable to systematic production methods. Traditional military thinking said artillery required specialized craftsmen and specialized facilities. American industry proved that artillery required systematic engineering and industrial organization. The transformation from 3 howitzers per month at Rock Island Arsenal in June 1940 to 2,000 per month from multiple assembly plants by early 1944 represented more than increased production. It represented fundamental reimagining of how weapons could be manufactured. Traditional approaches assumed production constraints were inherent limitations. Industrial approaches treated constraints as engineering problems to be solved through systematic analysis. Every problem encountered during the transformation was solved through systematic methods. Inadequate machine tools were replaced with specialized equipment designed for artillery production. Insufficient skilled labor was replaced with training programs that taught specialized tasks to unskilled workers. Complex assembly procedures were broken down into simple, repetitive operations that could be performed quickly and accurately. Quality issues were addressed through statistical control methods that prevented defects rather than detecting them afterward. The result was a production system that could scale almost infinitely. The limiting factors became raw material availability and factory capacity, both of which could be increased through investment and time. Labor constraints were eliminated through training and specialization. Design constraints were eliminated through standardization and simplification. Time constraints were eliminated through parallel production and systematic scheduling. Traditional production limitations simply disappeared when industrial methods were properly applied. This transformation was not unique to artillery. Similar patterns appeared across American military production. Tanks, aircraft, ships, vehicles, ammunition, and equipment all saw production increases that seemed impossible by traditional standards. In each case, the transformation followed similar paths. Industrial engineers analyzed production requirements, identified constraints, engineered solutions, and implemented systematic production methods. The results consistently exceeded predictions and shattered assumptions about production limitations. The common thread was industrial thinking applied to military problems. Traditional military production was craft-based, small-scale, and labor-intensive. Industrial production was system-based, large-scale, and equipment-intensive. Traditional production emphasized individual skill and craftsmanship. Industrial production emphasized systematic procedures and statistical control. Traditional production was limited by skilled labor availability. Industrial production was limited by capital equipment and raw materials, both of which could be increased more easily than skilled labor. American industry brought decades of mass production experience to military production challenges. The automotive industry had perfected systematic assembly of complex mechanical products. The machine tool industry had developed equipment capable of precision work at high speeds. The steel industry had learned to produce specialized alloys in large quantities. When war came, these capabilities were redirected to military production with remarkable effectiveness. The speed of transformation was as impressive as the scale. From essentially zero military production capacity in 1940 to peak production exceeding all other major powers combined by 1943 required just 3 years. This rapid transformation was possible because the underlying industrial capacity already existed. It simply needed to be redirected and scaled up. Building that industrial capacity had taken decades, but once it existed, mobilization was remarkably rapid. German military planners had assumed American industrial mobilization would take many years to affect the war's outcome. They believed Germany could achieve victory before American production reached significant levels. This miscalculation cost them the war. American production reached overwhelming levels much faster than German predictions suggested, and did so while simultaneously building naval and air forces that further stretched German resources. The artillery production story encapsulates this broader mobilization. In June 1940, the United States could produce 3 howitzers per month using traditional arsenal methods. By June 1943, American factories produced more than 1,600 howitzers monthly using industrial mass production methods. This 530-fold increase in 3 years seemed impossible by traditional military thinking, but it was achieved through systematic application of industrial production principles. The lesson remains relevant today. Military capability is ultimately determined by industrial capacity and production efficiency. Superior training and technology provide advantages, but overwhelming material superiority remains decisive. Modern military planning recognizes this reality and emphasizes maintaining industrial production capacity that can be rapidly expanded during crises. This recognition traces directly to World War II experiences, particularly American artillery production. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now and don't forget to subscribe.